The concept of alternate universes is very popular. Perhaps it's the appealing idea of a perfect world where you get a second chance and things might work out differently. Or maybe an alternate reality where you get to travel throughout time, where you can see universal scale experiments, and where you never have to limit your imagination. However, is there really a place in science for such speculation? After all, the universe is everything that there is, and you can't have two versions of everything, right? Otherwise, the pair would really be everything, and what you originally called the universe wasn't everything after all. When faced with this problem, scientists decided to combine the different possible universes into a single infinite set. This set is known as the multiverse, and today we are going to explore two variations of the multiverse as well as a possible key to connect them all. This is a deep dive into the multiverse theory. Before we fully dive into the different variations of the multiverse theory, first let's take a second to understand the base concept. The multiverse is the hypothetical set of all universes. This means that any parallel or alternate universe you can think of exists within the multiverse. Somewhere out there is a version of you who is the smartest human being to ever live. Somewhere else is a version of you that is more aligned with Hitler. Every combination of different physical laws and constants can be found when looking throughout the multiverse. A universe exists where the speed of light is slower than a turtle, and so does one where gravity itself is non-existent, preventing the formation of any stars or galaxies. The point is that all instances of both time and space are present in the multiverse. This overbearing property of the multiverse theory explains another physics concept known as the anthropic principle. Do you remember when I mentioned that some universes have different light speeds and some don't have any gravity? Well, that is the main idea. Of all of these universes, it is possible that humans in their current form could only have evolved in our current universe. The anthropic principle describes this coincidence as the fine-tuning of the universe. However, the multiverse theory helps put this to rest by suggesting that fine-tuning is just an illusion. After all, every possible universe does exist, so why wouldn't we evolve perfectly to live in this one? While thinking of alternate universes seems like a very modern endeavor, you might be surprised to hear that this idea was first explored in ancient Greece. As we explore the roots of the multiverse theory, we find many parallels in the works of the ancient Pythagoreans. The Pythagoreans were followers of the great philosopher Pythagoras, who lived in the 6th century BCE. Pythagoras had a significant influence on the development of mathematics and how we view the cosmos. He and his followers believed that the universe had an absolute and harmonious mathematical order. Because of this, they also believed in the concept of a plurality of worlds, which claims the existence of alternate realities to our own, governed by alternate mathematical laws. While the Pythagoreans never explicitly proposed the idea of a multiverse, there is no doubt that they laid the foundation for our understanding of multiple worlds. Their work would continue to be expanded upon throughout the Renaissance by individuals such as Marsilio Ficino and Johannes Kepler. Now that we are armed with the work of ancient philosophers and the contemporary thinkers of the Renaissance, it is time to venture forth towards the original multiverse theory, a way of understanding physics that helps to explain the origins of the multiverse set. As we continue to dive deeper into the journey of the multiverse theory, we come across a concept that is widely mistaken to be the multiverse theory itself, and that concept is the many worlds interpretation. During the 20th century, the problems of quantum superposition and wave function collapse left physicists around the world completely stumped. They tried to come up with many different interpretations of quantum mechanics to help explain some of these problems. One of these scientists was Erwin Schrödinger, who proposed his Schrödinger's cat thought experiment to highlight his problems with the Copenhagen interpretation of quantum mechanics. Another one of these scientists was Hugh Everett, and instead of trying to attack an already existing interpretation, he decided to come up with his own. This interpretation is none other than the many worlds interpretation of quantum mechanics. It is believed that when Everett first proposed this idea, he was met with skepticism from the physics community, including his advisor, John Wheeler. However, despite the initial resistance, the many worlds interpretation has gained traction traction over the years and has since become a serious topic in physics. But what is this many worlds interpretation, and what does it have to do with the multiverse theory? When you woke up this morning, you had the choice to either get out of bed or turn over and go back to sleep. A little bit later, you were faced with the decision of what to eat for breakfast, toast with eggs or cereal. Then, on your way to work, you must choose which route you're going to take. Our entire day is filled with these seemingly insignificant decisions, but you might have heard someone say that these decisions add up. Well, with the many worlds interpretation, it is as if these decisions are all equally significant. When you chose to get out of bed, you created a new universe in which you got out of bed. However, at the same time, you created a new universe in which you turned over and went back to sleep. This and every other decision you made this morning would have each given rise to a new universe, one with just one slight difference: your decision. You see, in the Copenhagen interpretation of quantum mechanics, this scenario is best described as superposition. Imagine if it was possible that you were both out of bed and going back to sleep at the same time. This could be possible because someone in your family might not know whether you are asleep or not until they go and check. But many worlds has a slightly different idea. From the time you were born, you have been making decisions and in turn splitting your reality into a seemingly infinite number of alternate universes. And while you might believe that what you had for dinner one night 7 years ago is completely insignificant, it is possible that this one meal could have determined the rest of your life. Let's say that you really wanted to order pizza, but instead you decide to eat some leftovers. In another universe, you did order pizza, and because of this, there was another customer who received their pizza later than they should have. Already having a bad day and upset about their late delivery, they might decide to go to the bar and have some drinks with their friends. After a long night, they decide to irresponsibly get behind the wheel and make their way home. You wake up the next day feeling a little sick from the greasy pizza, wondering if you should have just stuck with the leftovers. You get up and go to work, but on your way you are struck by a drunk driver, ending your life. This drunk driver just so happens to be the same customer who received a late pizza the day before. This leads us to a concept known as the butterfly effect. In chaos theory, the butterfly effect describes the situation where a small change in input can lead to a drastically different output. For example, the winds that blow around the earth are very complex and at this point beyond our understanding. However, one thing that we do know is that these winds are very sensitive to small changes. Say you have a butterfly on the coast of California. By flapping its wings and displacing a seemingly insignificant number of air particles, it can create an evolution in the wind pattern, turning this initial displacement into a complete F5 tornado by the time it reaches Florida. This exact scenario is what gives the effect its name, and now that you understand it, it is time to explore what this means for the many worlds interpretation. We already know that according to this interpretation, every time you make a decision, the universe is split into two parallel universes, a name that doesn't really make sense when considering how they are formed. One important thing that I forgot to mention is that this isn't just unique to you. Every decision made by every human, or possibly non-human, who has ever lived, has split our universe into two alternate ones. This, mixed with the butterfly effect mentioned earlier, is what gives rise to the development of completely different and unique universes. And as these get split further, we eventually see an infinite number of possible universes, more commonly known as the multiverse set. Now, after exploring the many worlds interpretation and the butterfly effect, you can probably see why so many people confuse this interpretation with multiverse theory itself. But to end things off, I will give you a simple difference between the two. The multiverse theory describes the set of all possible universes, and the many worlds interpretation, at best, explains how this set comes into existence. Whether or not you agree with the many worlds interpretation, it has become a large subject of discussion in the field of quantum mechanics, and it has even been explored more recently in pop culture. Whether it is the Marvel Universe or Rick and Morty, we have seen these characters travel to alternate universes and even create new ones simply by making a decision. I could easily make an entire video on the many worlds interpretation, but for the sake of this one, we are going to move on to another variation of the multiverse theory. What if each universe in the multiverse set existed independently from one another? Well, the bubble universe theory says that they do, and helps to further strengthen the multiverse theory as a whole. This theory was first proposed by Russian-American physicist Andrei Linde, who sought to define the implications of an eternally inflating universe. You have most likely heard before that the early universe underwent a period of rapid expansion. This is called inflationary cosmology. Inflationary cosmology claims that this rapid rapid expansion took place within a tiny fraction of a second after the Big Bang, and that it is the cause of our universe's flatness and homogeneity. Linde, along with other physicists, further proposed the idea of eternal inflation, or an infinite inflation period occurring in the universe, and Linde later proposed that it might even give rise to the multiverse in his bubble universe theory. As I said before, during the first second after the Big Bang, we would see the entire inflationary period commence, in our universe at least. You see, there is no reason to believe that this irregular event completely stopped after less than a second. It is possible that this period stopped at different times in different regions of this greater universe, or the place where the Big Bang occurred. It is also possible that there are regions in the universe where this period is still taking place today. However, as some regions stop expanding and others continue, we see the formation of universe bubbles, completely separating these different instances of cosmic inflation. Due to the differences in this inflation period, the regions inside of these bubbles would have undergone different types of symmetry breaking, leading to completely different cosmic evolutionary paths. A symmetry break is the concept of breaking physical symmetry, or the consistency of a system after it undergoes many changes. The best example of symmetry breaks in our universe is the Higgs field, which gives rise to the bosons that are the mediums of the fundamental forces. Without symmetry breaks, we wouldn't have things like electromagnetism and gravity. Now that you understand the concept of symmetry breaks, you can likely imagine the implications for different types of symmetry breaks in other universes. But let's go back to inflationary cosmology to further explore how these different universes could evolve. This period of immense expansion was only made possible by the presence of the inflaton field, and this field contained the universe's first ever quantum fluctuations. A quantum fluctuation is any random change in the amount of energy in a point in space, something that occurs naturally in our universe due to a concept known as Heisenberg's uncertainty principle. During the period of inflation, these fluctuations are also stretched, and this creates a difference in energy density throughout the universe. These energy density differences, or perturbations, are the basis for gravity to start forming cosmic structures. A bubble universe separate from our own might have different quantum fluctuations that lead to completely different cosmic structures. The stretching of these fluctuations in our universe has left imprints that can be observed in the cosmic microwave background, or CMB. The CMB is the faint glow of radiation that fills our universe. It is the leftover radiation from the hot dense state of the early universe, specifically from the time of recombination, which occurred approximately 380,000 years after the Big Bang. During this recombination, the first atoms of the universe would be formed, and the first photons would be released. Many scientists believe that this period is the most responsible for the laws in our current universe. Now, the CMB is uniform in every direction you look, and researchers have even learned to find certain patterns in the CMB that might indicate the influence of different physical conditions in different regions of the multiverse. In a nutshell, the CMB is a snapshot of the early universe, and also a map of its evolution, and researchers continue to investigate whether certain patterns or anomalies in the CMB could provide further evidence for the existence of the multiverse. While the bubble universe theory started as support for the theory of eternal inflation, it has since become a topic of both extensive research and serious scientific discussion. Now that you understand the bubble universe theory and how it might inherently imply the existence of the multiverse, it is time to move on to the final topic of this video. While quantum entanglement is not a variation of the multiverse theory, it may be the one key that could help us understand it all. Quantum entanglement is when a system is in a state of superposition. But what does this mean? The most common example is flipping a coin. If you flip a penny but don't look at the result, then you know that it can either be heads or tails, you just don't know which. Superposition means that the result is not just unknown to you, the outcome of heads or tails does not even exist until you observe it. Quantum entanglement is a special kind of superposition, two separate locations in space as opposed to two results in just one place. An example of this would be measuring one photon from a beam of light entering a beam splitter. The photon has a 50% chance to move to path A and a 50% chance to move to path B. But until you measure the results, the photon is in a state of superposition in both paths. Let's say you look at path A and you find the proton. Then you might assume that it was there all along. However, with quantum physics, assuming properties such as this about a particle leads to measured results that aren't possible. This goes back to the Heisenberg uncertainty principle we talked about earlier. While quantum entanglement once baffled even the brightest minds, including Albert Einstein, in the modern day it is recognized as a fundamental part of quantum mechanics. Let's go back to the penny example. Except this time you will have 10,000 pennies instead of just one. These 10,000 are made up of 5,000 entangled pairs. If you were to drop the 10,000 pennies onto the floor, then it would be safe to say that each of them has a 50% chance of being either heads or tails. However, you pick up the first penny and observe tails. Once you make this observation, the other entangled penny in this pair will no longer have a 50% chance of being either heads or tails. You know that it is 100% tails. This information travels from one penny to the other faster than the speed of light, and this phenomenon left scientists stumped for decades. Although recently scientists have determined that the peculiar nature of entanglement shows that the information that travels faster than light doesn't carry any useful information until actually measured. While quantum entanglement seems to challenge the universe's speed limit for information, it also doesn't seem to have any physical limitations as far as distance is concerned. What does this mean? Well, let's say when you picked up the penny that read tails, the other penny wasn't in the same room. Instead, it was on the other side of the universe. Even with some 20 billion light years of distance, you can say with 100% certainty that the other penny also landed tails. This rule-breaking property of entanglement is what will lead us back to the discussion of the multiverse theory. Quantum entanglement provides a fascinating link that surpasses the conventional ideas of space and time in the overall context of the multiverse theory. The entangled particles provide a glimpse into a complex web of interlinked realities that reaches well beyond our current understanding. Although these particles appear to be independent, they remain inescapably linked, and when this gives rise to the transfer of information, we get a concept known as instantaneous correlation. You see, what if the entangled counterpart of the penny you chose was actually in another universe entirely? Up to this point, assuming the existence of a multiverse, we don't have any reason to believe that it isn't possible. In this alternate universe, another being is making a bet and flipping the penny. Right before they observe their penny, you observe yours, making certain their penny would also be tails. Regardless of their prediction and the previous 50% chance, it would seem like you have decided their fate. This is exactly what I meant when I said you cannot assume a characteristic about a system before you measure it. This instantaneous correlation could affect our entire universe in similar ways to the penny example. Unlike the bubble universe theory, this idea suggests the different realities of the multiverse are in a way entangled, and that every action in one universe creates an action in another universe. But even if every particle isn't entangled with another particle in another universe, the existence of just one of these trans-universal pairs has profound implications. This could be the one way to truly interact with parallel universes. It might be that one day we will discover being in another universe, and in the same way they will discover us, and quantum entanglement might just be the key to making this a reality. Now that we have taken a deep dive into the true nature of the multiverse theory, hopefully you have learned some of the implications it could have on our world. However, as with many of these universe theories, you may find that there are no implications at all, and that it is just food for thought. No matter how you choose to look at it, there are thousands of scientists searching for this answer every single day. We have created many theories surrounding the multiverse, but the reality of quantum entanglement might be our only hope of truly understanding it. While now we are only able to create entangled particles, one day we might be able to create entangled systems that would interact with one another in ways we can't even begin to understand today. Hell, it might even be possible that the universe itself is entangled with another universe, and somewhere out there another version of you exists seemingly independent of you, but inescapably linked. The inside of a black hole is perhaps the strangest place in the entire universe. If you just so happen to be unlucky enough to find yourself falling into one, you would be met with a seemingly infinite lasting but likely still painful death. As you pass the event horizon, your legs and feet would start to accelerate faster than the rest of your body, causing you to be stretched infinitely thin in a process known as spaghettification. Our universe is so big, it's easy to believe that nothing outside of it can exist. But what if I told you that scientists have theorized that our universe exists inside of a black hole? This may sound crazy upon first hearing it, however, after 13 billion years since our universe's beginning, it might be our best guess as to how. This This theory has gained significant ground in the physics community over the last few decades, and today we are going to explore the possibility of this theory as well as some of its implications. This is a deep dive into the black hole universe theory. If you wanted to turn the Earth into a black hole, you would have to compress all of its mass down to the size of a marble. This means all of the mountains, cities, and oceans are packed into a space smaller than an inch wide. However, this would be extremely small compared to the black holes we have observed in the universe. In fact, most known black holes far surpass this scale, with masses up to tens of billions of times that of the Sun, and sizes that would engulf our entire solar system. The largest black hole ever discovered is Ton 618. Located 10.3 billion light years away in the constellation Canes Venatici, this behemoth boasts a mass of over 66 billion suns. And while this alone is a size that we cannot even imagine, it still dwarfs in comparison to the size of the entire universe. You have likely heard that the observable universe is expanding. But what is it expanding into? Well, the observable universe currently spans around 96 billion light years in diameter, but it is possible that the entire universe continues forever. What we do know is it just so happens that if you wanted to turn our universe into a black hole, you would have to condense all of the mass from the entire universe into a sphere just slightly larger than the observable universe. When faced with this logic, scientists came up with a concept known as black hole cosmology, claiming that our entire universe exists within an enormous black hole. While we wouldn't be able to cross the event horizon, it turns out that as long as the black hole is large enough, we would be completely safe. How could living inside of a black hole be safe? Well, let's go back to the idea of an observable universe. 48 billion light years away in any direction is the cosmic horizon. This is the boundary that separates our observable universe from the greater universe. However, this boundary, much like the event horizon of a black hole, is not fixed. No matter where throughout the universe you travel, or how fast you go, the cosmic horizon will always be 48 billion light years away in every direction. Surprisingly, scientists claim this is remarkably similar to what would happen inside of a black hole. They say that from the inside, the event horizon would behave identically to the cosmic horizon of the observable universe. But how do they know this? While there's no direct evidence for what the inside of a black hole really looks like, over the last century we have seen progress in the field of physics that has helped us make educated guesses. In 1915, Albert Einstein introduced the very concept of black holes through his theory of relativity. In his theory, we see gravity as the curvature of space-time as opposed to just a pulling force. Imagine if you had a flat blanket. If you had a bowling ball, then it would create an indent in the blanket. Now pretend the blanket is the space-time plane and the bowling ball is a massive object, such as the sun. If you added a baseball, or the earth, then it would create its own indent, but would inevitably be caught up in the indent of the bowling ball. Instead of one massive object attracting another, it changes the very essence of time and space, which makes other objects act accordingly. Einstein's theory also gives us a glimpse into how black holes affect our current universe. By suggesting that time is relative, Einstein introduced the concept of time dilation to the world of physics. If you've seen the movie Interstellar, then you know exactly what I'm talking about. In the movie, a group of scientists travels to a planet to find a new home for humanity. However, instead of a star, this planet orbits a supermassive black hole by the name of Gargantua. Due to the intense curvature of space-time around the black hole, the crew experiences perhaps one of the most intense cases of time dilation. You see, for every hour that they spend on the planet, 7 years would pass on Earth. After running into obstacles during their research, they spent around 3.5 hours on the planet. Once they successfully escaped the gravity, they realized that a whopping 23 years had passed on Earth. It can be hard to wrap your head around the concept of time dilation, but this really goes to show just how bizarre these massive space objects can be. Where do these black holes come from? Well, at the end of a star's life, it has 3 possible outcomes, depending on its mass. Smaller stars, such as our sun, will slowly release their matter in the form of planetary nebula, and then live on for billions of years as as white dwarfs. Stars that are much bigger, around 15 times the mass of the sun or more, will have a fiery end in the form of a supernova. After this truly galactic scale explosion, the star will either stay intact, turning into a dense neutron star, or for the largest of them all, it will collapse, forming into a black hole. When a truly massive star collapses, the waves of space-time flow inwards, leading to a point of infinite curvature at its center. This place, named the singularity, boasts not only infinite time and infinite space, but also infinite gravity, making it a seemingly perfect place for a Big Bang to occur, giving rise to its own ever-expanding universe, although we will talk more about this later in the video. Now, we only mentioned the introduction of the concept of black holes. However, alongside his theory of relativity, Einstein proposed his field equations to describe a gravitational field outside of a spherically symmetric mass. This set of 10 interrelated equations had profound implications on how we understand gravity and the very fabric of space-time. For the first time in over 250 years, we had a new understanding of gravity. With his introduction of these equations, Einstein was able to prove Newton's ideas of galactic scale gravity wrong. And surprisingly, during the first year, another physicist named Carl Schwarzschild was able to come up with an exact solution to the field equations for the limited case of a single, spherical, and non-rotating mass, which just so happens to perfectly describe one known type of black hole. A Schwarzschild black hole, or static black hole, is a black hole that has zero speed and angular momentum. And when describing this black hole, Schwarzschild inadvertently introduced the idea of the event horizon. He found that a static black hole must have a boundary around it, separating it from the rest of space. This boundary, known as the Schwarzschild radius, later became what we know today as the event horizon. He also found that when doing gravity calculations, both within and outside the Schwarzschild radius gave similar results, possibly becoming the first scientist to unintentionally give rise to the black hole universe theory. Deep within a black hole at its very center is the singularity. While it might be the most misunderstood concept in all of physics, pondering its implications has allowed us to come up with more and more intriguing theories. One such theory is the singularity of a black hole is the very connection of our universe to another. Is it possible that you can transcend reality and visit another universe by entering a black hole? This exact question gives rise to another concept known as the black hole Big Bang theory. But before we can explore this, we need to understand another concept called Hawking radiation. In the 1970s, Stephen Hawking came up with the groundbreaking idea that black holes eventually evaporate and meet their end through an idea known as Hawking radiation. Hawking claimed that throughout the universe there are virtual particle-antiparticle pairs that continuously pop into existence and annihilate one another. However, at the boundaries of a black hole, some of the particles get sucked in past the event horizon, leaving the other particle in the pair to wander aimlessly through the universe. After a time so long not even our universe has seen, the black hole will lose enough particles until it cannot hold itself together anymore, and it will collapse. This event would be much like that of a supernova, but to another level completely. Not to mention, we are not completely sure what would happen if a black hole collapsed into itself, but one guess is that it would create another universe entirely. Yes, really. Some scientists say that the singularity that started the Big Bang 13 billion years ago could have been the leftover singularity from a dead black hole, bringing us back to the black hole Big Bang theory. But what other implications does this theory have on our reality? Well, believe it or not, this is where things really start to get crazy. As we start to unravel the nature of black holes, we are confronted with two concepts that challenge our very understanding of the cosmos. The first of these concepts is known as the information paradox, and it can best be described with the following question. When an object is fully swallowed by a black hole, where does it go? The field of thermodynamics has given us laws to help explain the conservation of energy in our universe. Put simply, energy cannot be created nor destroyed, only transferred from one type to another. There is a very similar principle in quantum physics that describes the conservation of information. However, based on our current understanding of quantum mechanics, it seems that black holes completely ignore this rule. Not only this, we see the same paradox arise when studying the possible information loss that occurs during the Hawking radiation process that we discussed earlier. One proposed solution to the information paradox is the holographic principle. The holographic principle is essentially the idea that the information swallowed by a black hole is encoded onto its event horizon. This is an extremely complex topic that I plan on making an entire video about in the future. So for now, let's move on to the second concept, wormholes. Do you remember before when we imagined the space-time plane as a blanket? Well, now let's imagine if this blanket was folded over onto itself. The presence of a supermassive object such as a black hole could create an indent so deep that it creates a hole through both layers of the blanket, seemingly connecting them. Well, this is the idea of a wormhole, an object that bends the space-time plane in a way that can connect two distant regions of the universe in a type of tunnel. While this sounds like speculation, scientists have been taking this idea rather seriously and attempting to use it as a way to strengthen our overall understanding of gravity. One of these scientists was none other than Albert Einstein. Nearly 20 years after first introducing his theory of relativity and field equations, Einstein was collaborating with physicist Nathan Rosen when they came up with yet another proposed solution to the field equations. Alongside their solution, a new concept is introduced by the name of the Einstein-Rosen bridge, or the wormhole. You see, these two physicists were perhaps the first ever to imagine the distortion of space-time leading to these cosmic tunnels. And while they believed this bridge to be a one-way journey, subsequent theoretical analysis has introduced the idea of completely traversable wormholes. Going back to the context of the black hole Big Bang theory, it is possible that the Einstein-Rosen bridge could give rise to a new universe. What if by entering a black hole, you were inadvertently creating a brand new universe? This is a strictly theoretical idea, but like the information paradox, it is an attempt to answer one of the most important questions surrounding black holes. What happens to matter and information that has entered a black hole? While we have taken a deep dive into the mysterious nature of black holes, event horizons, and singularities, you might be shocked to hear that there's another object in the universe that is even more puzzling: dark energy. Dark energy is the invisible substance that fills the voids of the cosmos in between galaxy clusters. Pretty much all that is known about dark energy is that it is responsible for the expansion of the universe and for holding galaxies together. Something you might be surprised to hear isn't a responsibility of the black hole. Scientists believe that the supermassive black hole at the center of galaxies may have influenced the formation of the galaxy, but contrary to popular belief, these massive space vacuums actually have little to no effect on the gravity of a galaxy. However, as the most active and powerful bodies in the universe, the study of black holes might give rise to new ideas of just how this dark energy works. The inner workings of a black hole and our universe itself may be linked in ways that we don't currently understand. What if inside of every supermassive black hole, there was a completely new universe, which in turn was full of supermassive black holes that each contained their own new universe? This idea has also been used as an attempt to explain how the universe recycles itself, but we also haven't found any strong evidence to rule it out. While it might seem like pure speculation, this intriguing theory could provide new insights to the origin, expansion, and eventual end of the universe. Scientists continue to study this theory in order to determine what implications it might have on us. However, as with many universe theories, the only purpose might be to encourage you to think outside of the box. But when all is said and done, we know very little about the universe, and instead of trying to come up with our own theories, it might be a better idea to try and study the universe that already exists. Are we living inside of a black hole? Maybe, or maybe not. But to some, this is a much better argument than something like the simulation hypothesis, where we aren't even sure if the universe could sustain such hardware. Regardless of the implications for the future of humanity, we can acknowledge how far we have come in our understanding. It was just over 100 years ago when the likes of Albert Einstein and Carl Schwarzschild first explored the idea of black holes. Fast forward to 2019, we have captured our first ever image of a black hole, once and for all proving their existence and sending humanity into a new era of understanding the laws of physics and the universe itself. As a child, you were probably taught that atoms were the building blocks of our universe. While not entirely incorrect, this idea is also not the entire truth. You see, for most of history, the atom was believed to be the smallest thing in our universe. After all, it is named after the Greek word atomus, which means indivisible. However, around the middle of the 20th century, all of this changed. In 1964, Murray Gell-Mann and George Zweig were the first two physicists to propose the concept of quarks in an attempt to describe what really goes on inside of atoms. They described these quarks as the fundamental building blocks of these strongly interacting particles. At first, many viewed this strictly as a theory, but over the next several years, we would see significant progress in the field of quantum physics. In 1968, just 4 years after the first proposal of the quark, experiments at the Stanford Linear Accelerator Center were able to actually prove the existence of these particles. By colliding electrons and protons at very high speeds, scientists were able to discover these even smaller particles being ejected in the aftermath of the collision. These quarks come in 6 different flavors. Yes, flavors. We have the up quark, the down quark, the charm quark, the strange quark, the bottom quark, and the top quark. The last of these being discovered in 1992 at the Fermi Lab in Illinois. Fast forward to today, we have expanded this list to include other types of elementary particles, such as leptons and bosons. This table is modernly known as the Standard Model of Elementary Particles. With this list gives rise to the Standard Model for Particle Physics, which is an equation that attempts to describe the fundamental forces of the universe using boson elementary particles. We have the photon, which is responsible for the electromagnetic force, the W and Z bosons, who are in charge of the weak nuclear force, and gluons, which control the strong nuclear force. However, there is still one fundamental force that this model fails to explain: gravity. While there is a proposed boson deemed the graviton, we have yet to find any evidence of it, and this is where the standard model starts to break down. What makes gravity so hard to understand? Well, think about it like this. The Earth is a massive body with a mass of about 13 trillion pounds. And while you have a mass not even 0.01% of this, you are still able to move around freely and even jump against Earth's gravity. Not to mention, as you go further away from the Earth, this gravitational force diminishes rapidly. Of all the fundamental forces, gravity is by far the weakest. And up to this point, our best guesses as to how to explain it have been given to us by Albert Einstein. Einstein came up with his famous theory of relativity to describe the concept of gravity as the curvature of space-time itself. Space-time is like the plane of existence for our universe, and all of the matter in the universe is on this plane. Depending on how massive an object is, it will indent the plane, and since a smaller object would have a smaller indent, they commonly find themselves inside the indents of other, more massive objects. These indents are gravity, or in Einstein's words, the curvature of space-time. This theory of general relativity has been tested and confirmed in many experiments. However, these situations all involve a strong gravitational field or high velocity. In other situations, such as the behavior of matter on the quantum scale, even this great equation is unable to help us. This really goes to show just how large of a challenge gravity is. Fortunately, other scientists have come up with a possible solution, and if this solution is truly able to unify the standard model to general relativity, it could give rise to a true theory of everything. Before we move on to the next part of the video, I just want to thank you all for watching and supporting the channel. If you would like to meet like-minded people and talk about the topics covered in my videos, or even get a chance to talk with me, then make sure to join my Discord. The link will be in the description. What if the quarks that we mentioned before could be broken down even further? Well, string theory states that they can, and that once broken down to the final state, you get a one-dimensional string as opposed to a single point. And this string has a specific vibration. This vibration determines which particle will be created. A unique vibration for photons, and another for neutrinos, and even one for the proposed graviton. Could this be the missing link to truly understanding gravity, and in turn time, everything in the universe? Well, let's explore what this could mean for the future of humanity. With the complete control over gravity and its counterpart, anti-gravity, we would be able to create actual perpetual motion machines at the most fundamental levels. This could give rise to potentially infinite energy, overturning everything we thought we knew about the universe. We would have the ability to alter gravitational fields individually and essentially change the mass of any object. Eventually, we would become masters of both time and space, bending the space-time plane at our will, making us capable of things such as time travel and teleportation. Not a corner of the cosmos would remain unknown, and throughout all of time, we would be able to track the entire evolution of the universe itself. Such technology could very easily send humanity to the highest levels of the Kardashev scale, and even beyond. For those of you wondering, the Kardashev scale is a method for ranking a civilization based on their energy production, and with perpetual motion technology, a civilization would have essentially infinite energy production. However, as with everything else, there is a catch that might force all of this to remain nothing but a dream for humanity, and even make string theory completely useless. While on paper, string theory seems to solve all of our problems, all of these calculations have been done in model universes, ones that contain up to 10 different dimensions. In stark contrast, ours only contains 4, the 3 spatial dimensions and time. When scientists try to remove the extra dimensions, they run into many problems, rendering string theory unusable. But this doesn't mean that we should give up on it entirely. You see, maybe string theory isn't the theory of everything we were hoping for it to be, but this doesn't mean that it isn't a large step in the right direction. We have managed to describe 3 of the 4 fundamental forces of the universe in less than 200 years. If we are able to keep it up and even introduce new methods of research through means of more advanced technologies such as AI and quantum computing, it is possible that we are already well on our way to a theory of everything. However, after exploring the potential implications of such a discovery, I'm sure you would agree that no matter how long it takes, it will have been worth the wait. We must also understand, as with every discovery humanity has made in the past, the more we know what we don't know. It is possible there are more fundamental forces that we haven't even learned to observe yet. It is possible that our universe has more than 4 dimensions that we aren't able to perceive and never will be. At the end of the day, solving the universe is the biggest goal any of us could possibly tackle. Literally. While there's no telling how far away we are from understanding the true nature of the universe, it is very easy to look back and see how far we have come. It can be hard to appreciate the victories we have achieved as a species in light of everything we have yet to overcome. However, as time goes on, we continue to add to our list of achievements until eventually we will reach an understanding. There's no telling how long this would take, but at the same time, it doesn't really matter. All we can do today is keep learning, keep experimenting, and keep moving forward. And one day, our descendants will look back with pure gratitude at what we will have achieved. The internet is dead and nobody on it actually exists. What if I told you that the internet as we know it is not what it seems? Even though it started off as a place for niche communities to interact with amongst themselves, the internet has evolved in many ways, and some of these ways might have terrifying implications. What if every picture, video, and post you have interacted with is the work of highly trained artificial intelligence with the intent to distract and manipulate you? This is called the dead internet theory, and today we are going to explore just how likely and dangerous this could be for the future of humanity, possibly turning the digital world into a complex matrix in order to keep us distracted and compliant. Originating from the dark corners of the internet, this unsettling theory is backed by many patterns and thought-provoking evidence that might even convince you. This is the dead internet theory, and the story of how artificial reality may take over the internet, eventually leading to the total collapse of society. The field of AI has seen steady progress throughout its brief history. While for many years it seemed like just another science fiction technology, we are now able to observe many practical and impractical changes AI has already brought into our lives. But to someone who doesn't know much about AI, it can be hard to understand exactly what makes it so special. You see, the human brain is capable of executing anywhere from 100 billion to 1 billion billion operations per second. However, these operations are split between the many things that keep us alive, the functioning of our organs, the moving of our body parts, and even possibly the processes that give rise to consciousness. As an AI without a living body and without a consciousness, you would be able to dedicate all 100 billion of these operations to any process of your choice. While our brain is undeniably more efficient at solving some problems than any computer, there are even more problems that we cannot even begin to wrap our heads around, and this is where advanced artificial intelligence comes in to do the heavy lifting. A great example of this in our modern world is the explosion of AI tools made to automate one or more steps in any workflow process. Unfortunately, alongside the power given to us with these tools, we see a massive decrease in authenticity. Some programs such as DALL-E and Midjourney are able to create original high-quality images from a single text prompt. Others, such as Amazon's Alexa, are helping to connect every part of your life to a single network. One of the most popular and potentially the most influential AI apps is none other than ChatGPT. On its release in 2022, ChatGPT saw major success, amassing 100 million active monthly users in just 2 months. To put this into perspective, this number is equal to over 1% of the entire Earth's population in 2 months. While initially, ChatGPT's purpose was to make knowledge and learning more widespread and even to take the industry of search engines to the next level, something that hasn't been done since the introduction of Google in 1998. However, despite these ambitions, after its release, we would see many users of ChatGPT choose to use the AI-generated content in less ethical ways. If you are anything like me, then you have likely noticed a slight shift in your experiences with the internet since the introduction of these AIs. A shift from the feeling of freedom and expression to that of suspicion and shallowness. But this kind of AI abuse is not limited to ChatGPT. Nowadays, almost anyone has the ability to create an AI capable of mimicking human behavior in one or more ways. However, as with many other technologies, it is possible the government has had access for much longer than the public. What if I told you that for decades, these same tactics have already been in place, and in the pursuit of embracing the internet, we all failed to notice? In 2022, business magnate Elon Musk placed an offer to purchase the social media giant Twitter for $44 billion US. During this process, many studies were done to look into the amount of bot activity on the site, as Musk rightfully doubted Twitter's previous claim that less than 5% of monetizable users were bots. After being commissioned by Musk, the software company Cybra conducted 2 studies and estimated around 12% of Twitter accounts were bots. Not only this, but these 12% of users accounted for over 30% of all content on the platform. This caused the deal to be put on hold for several months before finally coming to a close. Although it is no surprise that Elon Musk would be skeptical about the volume of computer-generated traffic on social media. Besides, just 7 years prior, he was heavily involved with the AI tech startup OpenAI, the same company responsible for none other than ChatGPT. But what about some of the other social media platforms which have billions of monthly active users? The sad truth is that no matter where you look, it is the exact same story. For years, Facebook has been the target of many claims of inflated user stats in order to draw in more advertisers and investors. There has also been an apparent increase in click farms on the platform. A click farm is essentially one or more users interacting with content on the platform at a large scale in order to be compensated. While there is no direct evidence that Facebook is truly guilty of these claims, it would also be naive to believe that they are completely clueless. Instagram is another one of these platforms that has had a significant amount of bot activity. Ariana Grande has a resounding 194 million followers on Instagram. However, it is reported that 25% of these followers are fake accounts. That is around 50 million fake followers. Even YouTube has faced problems with AI-generated content, having to make multiple adjustments to their monetization policies, as there has been massive progress in AI voiceover and editing software, and by mixing this with the likes of ChatGPT, some creators have been pumping out loads of content with little to no effort. The bottom line is that these are the platforms that make up the current internet, and we already have proof that there is AI activity everywhere. What about the rest of the internet? For example, search engines or websites. Well, unfortunately, even these these sites are not safe from the dead internet theory. Have you ever noticed how you get shown articles throughout the year that are all basically the same? For instance, blue moons, or blood moons, or buck moons, or flower moons. You get the idea. I mean, in our busy day-to-day lives, we experience lots of different things. The moon, however, is something that remains rather constant. So why is it that we are constantly led to believe otherwise? What about when you're surfing the web and you come across a link that doesn't work? I'm not referring to a link that you cannot click on or is simply misspelled. Instead, these are called dead links, which direct you to sites that are permanently unavailable. As the internet grows and massive domains get moved around, a process known as link rot occurs, and we see an influx of dead links. Imagine if these links were the references on a research article, and without them, the article could be rendered completely unreliable. These are the sides of the dead internet theory that are important to note, mainly as supporting evidence. However, this is only half of the story, and the truth is, it only gets darker from here. In 2019, a man was taken into custody after allegedly using fake social media bot accounts to bully children into sending him money. He would have these accounts reach out to these children and make threats towards them and their families in order to blackmail them into sending him money. After a 6-month trial, he would be charged with nothing. That is because I made this story up to show how dangerous AI-generated content can be. Imagine an AI with writing and storytelling skills that are much better than mine, ones that even rival the most experienced humans. By creating stories such as this and spreading them throughout the internet, they would be able to create mass hysteria at alarming rates. But some AI are much more powerful, and instead of just creating false stories, they can create images and videos of real humans that are almost indistinguishable from reality. Take a look at this deepfake video. You might be able to tell the difference, but you can probably see why most people can't. Scary, right? Could you imagine what problems could arise due to the use of this fraudulent technology? The problem that best aligns with the dead internet theory is that which involves the widespread use of deepfake technology. Once people get used to seeing deepfakes more and more, they will learn to be more skeptical with the content they interact with on the internet. Hopefully. However, there might come a point where deepfake technology has perfected the art of replicating reality. And if the technology is mainstream enough, then it is possible that the entire internet will become completely AI-generated content. Would you want to go on the internet knowing that you might be experiencing something that is completely artificial or dead? You might be surprised that most people would answer yes to this question. After all, we have already explored how this is already happening on the biggest social media platforms, and that still doesn't stop them from being popular. This is the main essence of the dead internet theory. It is something that is very possible in the future with the use of technologies such as deepfake AI. So who says it couldn't already be happening on the current internet and we just haven't noticed yet? You could choose to reject this hollow internet, but at this point it may be so ingrained with our reality, it may be far too late. In October of 2021, Mark Zuckerberg announced the rebranding of Facebook to the technology company Meta. He did this in hopes of being given the reins to the creation of the metaverse. Whether or not this was successful is debatable, but that is a topic for another time. First, let's talk about what this metaverse is and why you should even care. The metaverse is defined as a hypothetical iteration of the internet as a single, universal, and immersive virtual world that is facilitated by the use of virtual reality and augmented reality. While this might seem like a lot to take in, it is actually very simple. A completely artificial experience entirely separated from physical reality, where the line between possible and impossible is eternally blurred. One where through the use of virtual and augmented reality, you would be able to experience anything you could imagine. This seems like it could be a utopia, where the harsh realities and circumstances that some of us so unfairly find ourselves in could become a thing of the past, where things like universe simulations and consciousness uploading is possible. But remember what I told you before. There are companies trying to take charge in the creation of the metaverse, meaning they would have the power to mold it to their liking. And unfortunately, it is improbable that this corporate metaverse would be anything like the aforementioned digital utopia. Since Mark has already made his intentions clear to us, let's use him as the antagonist of this scenario. In the recent years, there have been many lawsuits involving Facebook's privacy policies surrounding including the storing and security of private user data. This data is collected by advanced AI algorithms that have the only purpose of finding out everything about you. There are claims that after the collection, Facebook then sells this data to brokers and other companies. Imagine if by joining the metaverse, you are basically handing over any and all data surrounding your personal identity. While the selling of this data is already overstepping many boundaries, you might be shocked to hear that this isn't even the worst part. You see, the one thing that sets AI in a league completely separate from humans is data analysis. By feeding deep learning algorithms large amounts of seemingly unintelligible data, it will find patterns and in turn teach itself based on this data. This could mean determining your height, age, gender, and even shoe size, just based on how you move around and interact with your environment while wearing a VR headset. I know this just seems ridiculous, but this is really how this AI works. And it might not be possible now, but there's no reason to believe that it won't be one day. After these companies who control the metaverse have collected enough data to know more about you than even you ever could, it is time to completely change the status quo, one individual at a time. Before we fully dive into this rabbit hole, let's come back to the present. With the complete takeover of the internet, society has been met with many challenges. This is mainly due to the rapid progression of technology and the slow development of the human psyche. For hundreds of thousands, if not millions of years, humans have developed the need to band together, and one way that we do this is by alienating other groups. If you lived in a small tribe thousands of years ago, it is likely that you would live with some people that you didn't get along with too well. But when in the face of battle with another tribe, it is these same people who you would fight alongside. Because of this, you would learn to tolerate these individuals due to your common objective, survival. This is called a social filter bubble. But how is this reflected in the modern age through the internet? Well, there's a concept known as confirmation bias, and in essence, it is the interpretation of new concepts and ideas based on one's already existing beliefs. Think about if someone told you that the sky is red. You might look outside to check, but odds are that upon first hearing this, you feel that you're being lied to. While not many people argue about the color of the sky, there are many other things that they do argue about. Things like politics and social standards. The AI algorithms that run the social media platforms that we use have gotten really good at showing us content that we enjoy, but even more importantly than that, content that we agree with. This content fuels our confirmation bias and further strengthens our dogma. You could say the people in charge of what content we consume are the people in charge of our beliefs. So now that you understand both confirmation bias and social filter bubbles, we can finally jump into the final implications of the dead internet theory as it pertains to the metaverse. Imagine if you were in charge of a company that has complete dominance over the metaverse. You have access to data describing all of the users down to their toothpaste preferences, and you are in almost total control over their beliefs and opinions. By controlling every experience people have in the metaverse, you can lead them to follow whatever narrative you wish. With the use of AI, you could create fake friends for people to interact with, and by abusing their confirmation bias, convince them to partake in otherwise irregular behavior. You could control every article they read, every video they watch, every picture they see. This is truly an authoritarian wet dream, and hopefully by now you have started to see the dark reality of the metaverse. This future is not determined, and there is hope, of course, but as it stands now, if nothing changes, then one day sooner than you think, the internet will be dead. This has been the journey of the dead internet theory. If you enjoyed the video, please make sure to leave a like and subscribe. If you made it this far into the video, then comment metaverse to confuse everybody else.